Your child has been sitting at the dinner table for exactly 4 minutes. That is all it took. The chair is now a jungle gym. The fork is a drumstick. One leg is bouncing under the table so fast it sounds like a small engine. You have said, "Sit still," 3 times. It did not work. But here is the thing. The problem is not your child. The problem is the chair. More specifically, the problem is that you have been told movement is the enemy of focus. That stillness is a sign of attention. That a calm body means a calm mind. And that belief is not just wrong, it is backwards. According to decades of neuroscience research, movement is not what pulls children away from thinking. In many cases, movement is exactly what thinking requires. Your child cannot stop moving because their brain will not let them. And once you understand why, you will never tell a child to sit still in the same way again. Let us start at the beginning. Not the beginning of your child's life, the beginning of ours. For roughly 300,000 years, human children did not sit at desks. They did not sit in chairs. They climbed trees, ran between camps, carried things, built things, chased things, and fell down and got back up thousands of times before they were 10 years old. The human brain did not evolve in a classroom. It evolved in constant, unpredictable, full-body motion. Researcher Jaak spent decades studying the emotional and motivational systems of the mammalian brain. One of his most consistent findings was what he called the play system. This is not a metaphor. It is a dedicated neural circuit, found in every mammal studied, that drives physical, spontaneous, joyful movement. It is ancient. It is powerful. And in children, it is running at full intensity for a reason. The play system is not a distraction from development. It is the engine of it. When a child rolls across the floor, spins in circles, taps their fingers, bounces their knee, or turns a pencil into a tiny helicopter, their brain is not wandering. It is working. The cerebellum, long thought to only manage physical coordination, is now understood to be deeply involved in attention, cognitive processing, and emotional regulation. Every time a child moves, the cerebellum fires. And when the cerebellum fires, it sends signals that support focus, not undermine it. This is why researchers like John Ratey, a clinical professor of psychiatry at Harvard Medical School, argue that exercise and movement are among the most powerful tools we have for improving brain function. In his research, Ratey found that physical movement increases levels of brain-derived neurotrophic factor, which he calls miracle-grow for the brain. This protein helps neurons grow, connect, and survive. The more a child moves, the richer and more resilient their neural architecture becomes. Sitting still does the opposite. But there is something even more specific happening. Your child is not just moving. They are regulating. The nervous system in a young child is not fully developed. The prefrontal cortex, the region responsible for impulse control, sustained attention, and emotional regulation, does not fully mature until a person's mid-20s. In a 6-year-old, it is a rough draft, a sketch. When your child feels overwhelmed, bored, anxious, or overstimulated, they do not have the internal circuitry to simply decide to calm down the way an adult might. Instead, the body steps in. Movement becomes the regulator. This is called sensory integration, and it was first studied in depth by occupational therapist and neuroscientist A. Jean Ayres in the 1970s. Ayres proposed that the brain needs to constantly organize sensory information from the body, and that children who struggle with this regulation often seek movement as a way to help the nervous system make sense of the world. Spinning, rocking, bouncing, and fidgeting are not random behaviors. They are the body's attempt to achieve neurological balance. Think of it like this. When you feel nervous before a big meeting, you might pace. You tap your foot. You roll your neck. You are doing exactly what a child does every hour of every school day. You are using your body to help your brain cope. The difference is that nobody tells you to sit still. Now, here is where it gets counterintuitive. Research published in the journal Pediatrics found that children who were given structured recess breaks, even as short as 15 minutes, showed significantly greater focus and attentiveness in classroom settings immediately afterward. Not slightly better, significantly better. The children who moved the most during breaks were, on average, the ones who focused the most afterward. This directly contradicts the model most schools still operate under. The traditional approach treats recess as a reward for good behavior or a privilege that can be taken away. Movement is seen as the opposite of learning. But the science says that movement is not the break from learning. Movement is the preparation for it. So why does it feel like constant motion is a problem? Because in many modern environments, it is inconvenient, not because it is wrong. A 2014 study from the University of Illinois found that just 20 minutes of walking before a cognitive task measurably improved reading comprehension and attention in elementary school children. But the children who needed it most, those labeled as hyperactive or distractible, showed the biggest improvements. The children whose movement was most disruptive in a sitting environment were the ones whose brains responded most powerfully to physical activity. The movement was not the disorder. The stillness was the mismatch. This brings us to something uncomfortable. Some children are diagnosed with attention deficit hyperactivity disorder, commonly called ADHD, in part because their movement is excessive and disruptive. And while ADHD is a real neurological condition involving differences in dopamine signaling and prefrontal regulation, the question of where typical childhood movement ends and a clinical threshold begins is far more complex than a single checklist. Researcher Dimitri Christakis at the University of Washington has studied how overstimulating media environments may actually train young brains to require higher and higher levels of input just to feel engaged. A child whose nervous system has been shaped by rapid, high-intensity screen content may find a quiet classroom almost unbearably understimulating. Their movement is not defiance. It is the nervous system demanding the stimulation level it has been trained to expect. And even beyond screens, children who move constantly are often children whose proprioceptive systems, the internal sense of where the body is in space, are particularly active. When that system is highly sensitive, the brain needs more physical feedback just to feel grounded. These children do not choose to fidget. They need to fidget the way you need to blink. Here is what that means practically. A child who taps their pencil is often concentrating harder than the child sitting perfectly still. A child who stands at their desk to do work is frequently more productive than when seated. A child who needs to pace a few steps between tasks is not avoiding the task. They are preparing their brain for it. Studies using classroom designs that allow children to sit on wobble stools, stand at desks, or work on the floor consistently show improved focus, reduced behavioral issues, and higher academic output compared to traditional fixed-chair classrooms. Not because the children are different, because the environment finally matches the brain. Your child has not changed. Your understanding of them is about to. There is one more layer to this that parents and educators rarely hear about. Movement does not just prepare the brain for thinking. Movement is part of how children think. Developmental psychologist Susan Golden Meadow at the University of Chicago has spent decades studying the relationship between gesture and thought in children. Her research shows that when children use their hands and bodies while solving problems, they are not just expressing their thinking. They are actually doing the thinking. The movement is the cognition. Asking a child to sit still and think is, in some cases, asking them to think with one hand tied behind their back. This is why a child who acts out a math problem on their fingers gets it right. Why a child who walks around while learning a new word remembers it longer. Why a child who builds something understands it more deeply than a child who only reads about it. The body is not separate from the mind. In the developing brain, the body is a primary cognitive tool. So tonight, when you watch your child spin across the kitchen, or tap out a rhythm on every surface they walk past, or reorganize their chair into 5 different positions in 10 minutes, something different might cross your mind. Not frustration, not worry, something closer to recognition. That moving body is not fighting the brain. That is the brain. Alive, active, doing exactly what 300,000 years of human evolution designed it to do. And the fact that your child cannot stop moving does not mean something is wrong with them. It means something is very, very right.